So first of all, thank you for choosing this session. At least we have a couple of people. So this talk I've given a couple of times, so I think the exponential of growth for this talk keeps becoming better and better, so I'm improving as we go on. So the talk is more on demystifying big data, and once we demystify, I'll just show you how you can get quickly started with Google Cloud. Yeah. Okay, tech support. Okay, so just a little bit about myself. My name is Kenneth Kinyanjui. I'm a Google Cloud developer expert for cloud platform within Google. By the way, they don't pay us, so I'm just volunteering and sharing my knowledge with the community across the globe. My background spins on two fronts. One is software engineering, mostly focused on infrastructure. So think about scale and think about DevOps. Then the second part, think about product. So I did my last 2 years or more focused on product and sort of bringing technology and user experience and then the business. So binding it together, sort of focus on product for fintech. My background also has been in emerging markets. So I've had the privilege to work not just in Kenya, but with a couple of emerging markets, more so Francophone Africa, so about 16 of those markets, and hand in hand with some companies in Latin America, Southeast Asia, and India. I've started two companies. One is WeCashUp, and then I'm a co-founder at Faidika. So the essence of this talk is more about helping you understand what big data is, why we should care about it, when are we ready, like what's the whole concept of big data, and when should you be ready to start thinking about it? Is it at the start? Is it at the end? And how can we leverage on big data with ease? Because it seems like it's this big thing that everyone keeps talking about. We've been having sort of every time since 94 all the way to now, we've been having like a big wave. So in 94 it was the internet, and then everybody was like, in 2000 this internet thing will die. Then, coming to the 2000s, we have mobile, and then everybody went crazy on mobile. And then now we've been in the sort of age of cloud, around 2010, and people are talking about cloud computing and everything. Now we are talking about blockchain and AI. And so how do they come together? What has happened, and why should we care about big data? I wanted to ask a couple of people who think they know what big data is. Can anyone just volunteer? What do you think big data is?
I think it's just data that is like very large, like maybe terabytes in size.
Okay. So Professor Dan Ariely, who's written a book called Predictably Rational, and one of the most respected behavioral scientists now has this type of definition. So he says, big data is like teenage sex. Everybody talks about it. Nobody really knows how to do it. Everyone thinks everyone has done it before. This is not me. This is Dan Ariely. But in a way, a lot of the times people think about big data and they're always talking about it, but they don't really know. So let's try and demystify. So when you're thinking about big data or data in itself, you're thinking about 5 major things, and they're called the 5 V's of data. 1 is volume, 2 is variety, 3 is veracity, value, and velocity. Now, what are these 5 V's and why should you think about it? So as you start collecting data, your data starts growing over time. So he mentioned that it's data being stored in maybe megabytes, grown to gigabytes, grown to terabytes. So in this case, your data size matters, one. The second thing is variety. What are the types of data sources that you have? It can be metadata, it can be logs, it can be usage data by users based on your app. It can be historical data that's been collected over time. So data starts varying in different forms and how you collect it. Then there's also uncertainty in the type of data that you have. So in terms of as you keep doing your app, working on this product and its lifespan starts spanning, you always see that the data starts bringing in new trends and new patterns. You don't know, so you're like, okay, so what's happening? And the data keeps changing. You don't know which data point should I collect or this, and you keep learning over time. We just had our previous keynote speaker talk about Twiga Foods and their journey and how they have to iterate about up to 4 iterations on how they should think about their data and how they are collecting data and building products that supports their operations at Twiga Foods. The other thing is you can have as much data in petabytes and gigabytes, but if that information is not converted into knowledge, and that knowledge is not able to transform that into insight, then it's just a waste of time. So what's the value, what's the impact of all that data that you've collected? Can that data be used to sort of inform you in better ways of either untapping new markets or reducing costs or improving on efficiency, or lastly, like maximizing on your revenues? Then the last thing is velocity, like speed, the rate at which the data changes. So in a scenario where you start collecting data, for instance, user behaviors start morphing. Think of a product like Facebook or Instagram or LinkedIn or even Twitter. I'll give you a good case scenario. Twitter. When we started with just tweeting and doing things, then all of a sudden someone just introduced hashtags all of a sudden. And Twitter had to create a use case on how they'll capture, how do we track hashtags and how do we make hashtags more inclusive into our platform. Another thing is now what we have as Twitter storms. Normally what people used to do was someone will see, okay, we are limited to 160 characters, so what do we do? So they tweet 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then Twitter now morphed into that, and then they started looking, okay, so we are noticing this, people are tagging their tweets. Can we introduce threads and have Twitter storms? So your data will start changing based on how your users evolve and how people evolve in your ecosystem. Now, this is one, Gartner did a very nice chart about data and analytics and the value. So they did a chart where they on the y-axis we have value, and then on the x-axis we have difficulty. So let's talk about information or the data you've collected. So majority of the time you are starting with one, information that you've collected. And what's this information sort of telling us? So we always start with like saying what has happened, looking at our user logs. So in this case, in the first stage, you may be collecting user logs and then all of a sudden your server goes down. What the heck happened? You're asking yourself, what has just happened? And you want, okay, we know what has happened. The server is down and we've gotten a notification. Then you want to go deeper and diagnose, okay, why was this the case? Was this because some users sent a denial of service attack? Or was it because people did another use case and things happened and went in a crazy way? So you also want to be more diagnostics. Now, the part that most people really, and that's where the buzz is around with machine learning and AI, everyone is thinking about how can we build models that can now help us predict or even prescribe what will happen in the future. How can we even make it happen and make it possible? And this is sort of where now the whole concept of thinking about big data and how we store our data in a more better fashion that we can manage now starts to make sense. Because you can have diagnostic data, but as it starts growing exponentially, the constraint starts becoming more tough. So in the case where if you're now dealing with megabytes and a spreadsheet and collecting data, if everything is on a Google sheet, things are okay. But what happens when you have millions or 2 million types of users sending in data points, and then now your data is in the form of petabytes and terabytes? So how do you manage all that infrastructure? How do you get the same type of analytics? And now this is where big data comes into scale. How can I be able to understand my users, segment them, categorize them, label them, and know what information is good and nice? By the way, you can have big data and a lot of data, and it might seem like it's a good thing. It's always a good thing to have data, but majority of that data has noise. It's been reported that 70% of the work that data scientists do is data cleaning. 70% of their work is just cleaning the data and making sure that, okay, this is good data, we are working on that. So if they're spending 70% of that cleaning the data, imagine you have terabytes of data. A data scientist came into the job to sort of write a model and do this. So it seems that writing the models and doing the machine learning and the likes, that's the easy part. So how do we make sure that we have quality data that's, one, not biased, one that is trained to do the right things? And so that sort of now starts telling you that, hey, this whole big data thing is not just a facade or things. We have to put a lot of thought into it. Well, it's easier said than done. Sorry, I'm a big Steph Curry fan, and that's him making some amazing three-pointers and making it look so easy. But if you really want to think about big data, like these are the things that you start thinking about. One, where will this data live? So we have the concepts of data warehouse and data lakes. So how do we think about that? The second thing is all this data that's coming in needs to be processed. So we need computation to sort of process this data. We also need to stream it. So how does data move from one part to another? What's the data flow like? The other thing is, okay, we know that a lot of databases are more transactional. For those people who like computer science, in IT, like we even have like a unit called transaction databases. So you find people wanting to make their Postgres or do like things that it was not built to do. It was more of a transactional database. So how do you think about, first of all, getting a database that is using it for the right purpose, and then once you start hitting scale, you're moving it to the right tools that make sense for it? And how can this database also handle the scale that it's getting? The other part is you can do all these fancy models and the likes and leverage, but how do you understand the insight? How do you visualize this data? So that is also another part. The other part that is more critical, before even visualization, is how do you analyze this data? Do you have the right models? Do you have the right variables? And are you fixated on the right problem? And so I'll sort of paint a picture of what the big data ecosystem looks like. So if you are thinking of just managing big data at scale, and this is actually a mirror of how, I think this is a mirror of like Hadoop ecosystem, or how you would end up thinking about your big data, right? So before you even start getting more insight about big data, organizing it, you have to go and set up all this infrastructure. You have to think about, one, how am I going to stream this? So you have Spark there, you have SOLR, you have to manage monitoring and logging of this. You have to have a resource manager that allocates the right compute power to process the data. So there's a lot of things that are happening in this, and most of the people can tell you that this is actually a big pain. I had a couple of friends that were trying to set up their big data or data infrastructure internally, and this was a nightmare, because this was a data scientist, and he has to start first setting up all this Hadoop and everything, and learn, okay, am I more of an infrastructure? Now you've moved from the business of actually getting insights and analytics to now being more of an infrastructure person that's trying to think about, okay, is this the right thing? So But all that is just to simply do 3 simple things, but this is only when you're doing it at scale. So it's just to improve on how you access your data easily. Then you analyze it and visualize it, because it's all about input and output, and that input mapped to a certain model gives us a specific output, and that's the insight, right? So you have your data, comes into something, there's a lot of analysis, whatever, and then after that, you visualize and get the output. So all that just to do these 3 simple things. But in reality, it might look very simple, but it's like really, really tough. But what's the solution? How do we sort of think about this? And how do we think about how we can leverage on big data instead of focusing on the mundane task of setting up servers, and we are not focused on the business logic of getting insight? How do we do it? So one use case is Google Cloud Platform. There are many cloud providers, but there are many cloud providers. There's Google, there's Amazon, there's Windows with Azure platform. We have Alibaba Cloud. But I can say that Google has definitely had a big investment in how you sort of think about big data. And they have one of the most superior data warehouse as a service, which is BigQuery. But the whole essence is, I know this is supposed to be a technical talk, but a lot of times as technical people, we like to focus on the how and the nitty-gritty and getting all, coding and technical. But at the end of the day, you have to, and there's a lot of enjoyment in, can you imagine how proud you'll be after setting up a whole Hadoop cluster system, and then you're in this talk right now at DevCraft and you're saying, hey, this is how we did this and that, but at the end of the day, were you in the infrastructure building business, or were you solving a business problem for your company or your startup? Is that the right way of using your investor money and the likes as a CTO? So you're, okay, it's fun to do it, it's a learning process, it's amazing, but you need to focus on the real problem that you're solving and not lose time on managing infrastructure. So how do you abstract that? It's really fun to tinker around, but at the end of the day, does that return business, does that have your activity or your productivity, does that have a direct return of investment to the business? So, and in reality, and this is a very nice thing. I know I can talk a lot, but I've sort of also done a bit of consulting, and this is the use case that happens is this. One, you have your CTO or your CEO comes to a panel like DevCraft, a conference, and they hear about machine learning and blockchain. Then they come back to you in the office, you're the developer, and then they tell you, hey, I had this thing called machine learning and AI. So we have data, right? And they said you need data, you need hardware, and you need the models. Okay. I need to employ a data scientist. Can we start? I need to see some insights, some machine learning happening, and so that we can also put it in our slide deck and say we're using machine learning. And most of the time it's okay, so it brings this guy, and then they maybe go and get AutoML or one of the Google or cloud services puts it here, and then they say, okay, one, this is our machine learning system, and then the second one is okay, that's the data. It's in the database. So you see someone now putting in SQL, it's a pile of data, it's not being cleaned up, so, and then the guy's no, don't worry. Just put it there and we'll get some magic. And that's mostly how people do it, but I'm telling you, that's the worst way to do it. And you'll be first wasting time, wasting resources, and I think the best way is to think about your data in a more resource way. One good case study and company that I really like to reference is actually Twiga Foods, and we're lucky to have them as their keynote speaker. I had the benefit of interviewing Kane a while back and building a case study with him, and I noticed that they've been in operation, I think, for 3 or 4 years, and they still haven't done any big machine learning model and the likes. They're still in the data collection phase. They're very thoughtful about their data and doing just basic analytics. So if a company with the magnitude of a Twiga Foods has not even started deploying machine learning models to production, then and they are dealing with a lot of things. So it means that you really do need to think about your data ecosystem and what type of data and the quality of data that you're collecting. Majority of it, and this talk is actually like a primer to sort of help you think about how you can now leverage on the compute progress and the deep learning progress that, the breakthroughs that have come about. So in 2010, and moving forward from 2010 till now, we've seen a lot of breakthrough in computation. In 2006, we had this paper being written, and it was a big breakthrough in terms of deep learning, and then we just started seeing amazing stuff. So imagine 2006, deep learning and the computation, and now it makes sense for us to actually be able to apply machine learning and AI, because it can give us a big exponential. But for you to have like amazing machine learning and AI, it's three things. It boils down to three simple things: having the quality data, match the right hardware, and the last thing, match the right know-how. And you can really break down those components of those three things, but it's those three bubbles that you're thinking about. And in the know-how, you can break down on having the right data scientists, having the right cocktail of people to sort of not introduce problems such as bias and the likes. And this goes back to the quality of the data that you have, right? Because at the end of the day, there's no machine learning without a data set, without data. So how do you think about it? Definitely, I don't think anyone wants to be like that guy who does that. And how do we sort of think about it? I have this sort of tricks or matrix that I built a while back, and it sort of helps me, guide me, think about when is it right for me and how should I think about my data. Majority of the time I categorize companies in three stages. I think of them as one, early stage, high growth, and later stage. I normally have a couple of variables that I normally put into my axis, right? So I put users that they have, the team size. I put another one, are they cross-functional? And so Kane talk about this. I also look at their data. I look at, is agility a factor for them, and what about flexibility? Now, if you think about it, and in the grand scheme of things, if you're an early stage startups, you have just a couple of 100,000 of users, less than 20 people, cross-functional team, data sizes in gigabytes. Agilities, yes. Flexibility, not so, not so necessary, right? Like but agility is you have to deploy as fast as possible and experiment as fast as possible. Now, and many people can wear many different hats. In that type of stage, you have to think about what problem are we solving? Are we experimenting? Are we validated our model and the likes? And at that time, think about you're like more in a laboratory or lean type of model where you're doing a lot of experiments to sort of get product market fit. You're trying to see which model works, and then which one can give us the right return of investment, and now we can even go and get more funding from other guys. We have a model that makes sense and people can pay us. So in that stage, I wouldn't expect people to start now putting up like Hadoop clusters and the likes. It doesn't make sense. Like you can just start with Google Sheets and collecting data and putting things in the right way, collecting the right type of data and running the right experiments. When you're in high growth now, you're starting to think, okay, this data is now starting to grow, so what type of tools should I now start thinking about? This is now when you do the build versus buy, and you're like, do we build it internally, or is there a cloud provider who can actually give us something that can help us? And in this case, you can now think of moving your data now from, and we have a lot of nice integrations, so you can easily just export like CSV sheets or your SQL database into something like BigQuery and put it out there and start doing stuff. Let's say you even started your company and you are using a cloud data store, for instance, in this case, hypothetically, or you are using MongoDB. You can sort of now remove these collections and put them there and start thinking about, okay, let's look at what the data is telling us, right? And in this part, you want to think about how do we manage these experiments and scientific thing at scale. So now that's when you start thinking about tools such as what Airbnb has released, such as Airflow, with DAGs. Sorry for the technical jargon, but like there's a couple of tools that have been released by companies that are doing this. Spark, I think, came out of LinkedIn. I don't know if I'm wrong. We've seen companies such as Airbnb release things such as Apache Airflow. And we're seeing a lot of companies that have faced these problems at scale release like what they're doing and make it even open source, because they went through a lot of tough parts. So that's why you do like the, build versus buy. And at this moment, we have an amazing tech community globally that's been sharing a lot of tools and making them cloud native and open source. Now we even have a distributed way of thinking about pipelines with Kubeflow, right? So bringing the best of Kubernetes and distributed computing and thinking about TensorFlow and how you can now have Kubeflow where you can now deploy amazing machine learning pipelines. So how do you think about all these things? In late stage, you are very big. Let's say you have IPO'd, you have a ton of resources, you have a ton of engineers who can now sort of think about these problems, and the build versus buy now works towards your specific type of problems. Each of these companies, such as maybe Amazon or Facebook or Alibaba, are facing some specific type of problems that only them have only encountered and at some massive scale. So in their case, that's where you see that they will actually put in the right investment to sort of build tools to solve their problems at scale. And that's why we're seeing with what Airbnb did with Airflow and shared it, right? And things like such as Kafka or even Google releasing something like TensorFlow. These were internal tools that they struggled with. Google releasing PubSub. Like that's how they do a lot of event-driven works. And how do you bind all these flows? So the whole question is thinking about, okay, which stage am I at? Which is the right tool to pick? And don't over-engineer, use the right thing at the right time. And I normally have a couple of questions, and as you keep progressing as a software engineer, or thinking about a data engineering as a whole, you have to ask yourself these type of questions. One, which stage of the company life cycle am I? You might move from a Google or an Amazon and then go to like a small startup. You can't just start building Hadoop systems there. It doesn't make sense. So you have to ask yourself, where am I and where is the company? If you just move into if I start a startup again, I wouldn't be, I'll just start with scrappy spreadsheets and Google Sheets and small stuff. I won't even build the code. I'll just try to run as much experiments as possible before or maybe it would be just more of buying software, like get Typeform here, get this, get the right data, validate, and have more experiments, rather than if now we start progressing, like, okay, now we need to build some infrastructure to sort of do this. And even Twigger's story was similar, where Kane mentioned about how they started with a monolith and transitioned to microservices, but it wasn't like when they started, they were like, we're going to go microservices at the beginning. Then there's the other thing is, how is my data collection process? Am I collecting data the right way? This is where things such as user experience and how you user experience questions and how you frame questions make sense. So that you have to make sure you're more inclusive and you're not introducing bias to your data. Another thing is, are we making decisions based on our data, or are we hunch-driven? A lot of people, I know most of the time, and at the start you can be more hunches, but you need to validate them. So for me, it's more about scientific laboratory thinking and hypothesis, rather than being more of hunch. I can have a hunch, but I have to validate that hunch. And so if the company culture doesn't have experimentation and data-driven, all this big data, machine learning doesn't make sense. It only makes sense if you have laboratory thinking, scientific thinking, probabilistic thinking, where you're like, okay, we have to run this and see how it works. And then the other thing is my data accessible? Okay, we've stored all this data. So someone was telling me I've been collecting data since 2010 till now. It's in one MongoDB collection. And I'm like, okay, is that data? If you wanted to now, okay, if I asked you, okay, can you tell me X number of things? He was now struggling. He couldn't access the data. So it's not just about storing it. It's also, how can you access it? And then the other thing is my data clean? is there a lot of noise surrounding my data? So remember what we talked about. Don't give your data scientists the nightmare of 70% of their time is spent on just first cleaning the data because they can't make sense out of it. And the last one is like, can we confidently say we are a data-driven company? And this now boils down to some of those questions that you asked yourself. Just keep in mind, it's just 3 simple things. This whole thing, for me, when I started hearing machine learning, AI, data science, I didn't know where I was, and I was building tools to do things. Sort of when I paid keen interest, that's when I started saying, oh, okay. When I was thinking about product, it was like, oh, we're just collecting some data, analyzing it, visualizing. It's just input, output. I was like, it's really simple. But I know this, the whole exponential of people now narrowing down to some of the different, bubbles, and now it now becomes sort of very complicated, and people are talking about machine learning and TensorFlow and this, and you don't know. So where do I start? It's very simple. You just think about, okay, how are we collecting our data? How are you analyzing it? How are you visualizing it? And in the analysis part, how can we make our analysis efficient? Oh, we can actually use some compute power to sort of do this. Maybe we can add some machine learning to sort of accelerate this. Oh, our data collection is inefficient. Maybe let's try and see how we can collect that. So it's very simple, but like, I feel like because a lot of people want to make it like look like this very complex thing, or many people have really focused on a narrow field, then it always seems very complicated. So when you think about data collection, just think about one, it can be your app, can be your website, can be an API, can be just historical data that you're accessing, So it's simple stuff like, where is this data coming from? Is it being generated by users? Are you tapping into sort of historical text that was there before? Is it a manual? Are you trying to, think about it in those lines. Second part is like analysis. So I sort of mixed up like analysis, but analysis is more like, okay, what are the models? How we've cleaned the data, we've collected it. Now in the analysis, we are trying to clean it first. Once we've cleaned it, we put in some variables, and then we start doing some looking at the efficiency. So what's this data telling us? How can we look at a quantitative versus a qualitative model and trying to see, okay, based on, so this is a pattern we're noticing based on X, right? And the only way you do it is by, one, making sure your data is easily accessible, cleaning it, then crunching it in a way. And crunching means, you're trying to understand qualitative versus quantitative, like what is our data, what's the story that our data is telling us. And in this case, that's where now you actually put in some machine learning and AI, because in some exponentials or some situations where the data is in petabytes, it's really hard for the human eye to sort of process all that type of data. And now you need compute to sort of do that. So now you introduce, okay, we want to actually add a distributed system to sort of see how we can do this. And you're sort of now thinking about, okay, so how do we actually make sense of this data? Then the last thing is, once you've actually analyzed the data and you've understood the story that it's telling, you have to share it with the world. So it can be a model, and some models can be a graph, can be an output, can be a chart. So what's the output? What's the insight? What's coming out of this data that we've collected, and what's it telling us? There are a couple of tools on Google Cloud that have sort of helped people and done the heavy lifting, where you just pay per use. You don't have to buy all these servers and set up infrastructure and spend a lot of time doing this. So one amazing tool is BigQuery, which is Google's data warehouse. Another one is Dataflow, which is basically Apache Beam and Kafka put in as a managed service. We have Cloud Data Lab, which is more of the Jupyter notebooks put at scale. So imagine most of the time when people are doing like the machine learning and AI and they're writing, they're fed in the data, let's say from BigQuery. You write a Jupyter notebook, and that Jupyter notebook has to be attached to so many things, right? And with Cloud Data Lab, which just gone to general availability, basically you run your notebook and it's attached to some compute, maybe some CPUs, can be some GPUs, and you run it out scale. So you just come, write your notebook, describe it, plug in the right data, and you have your outputs immediately. Maybe you can connect them to something like Cloud Data Studio, where you visualize. So these, you don't have to you're actually more focused on the problem you're solving rather than the technicalities or the mechanics of how you get there, right? And so it's more about, okay, I'm in this type of problem, and this is how we want to get value. This is our problem. We are not in the business of building new infrastructure or getting DevOps. We want to do this. And a lot of companies have leveraged on this. We saw Spotify move completely to Google Cloud. And if people use Spotify here, they can attest that there's like one feature called Discovery Weekly, where they basically send you these playlists based on the amount of, like, the type of music you've been listening to, and they always get it right. Like after 3 weeks, that has been like my go-to playlist every week. I look forward to it. And these sort of small features that come out give your customers customer delight, and people, still remember, still stay and use this type of products based on customer delight. And so this is a good use case of a company that leveraged on machine learning and AI and didn't have to do all the heavy lifting. So they focused on their problems and how they can serve their customers, and not in the business of handling a lot of infrastructure. So how do you get started? Where do you start? So myself and James Moy, who's also a Google developer expert in cloud based in Nairobi, we run GDG Cloud Nairobi, which is a small meetup focused on industry people, intermediate expert. Conversations there are a bit advanced, just an FYI. But we also do run some study jams and some Saturday code labs on demand or on a needs basis. So beginners now can come on those like practical code labs and the likes, and sort of learn with us as well, because myself and James facilitate them, and you can actually upskill yourself. A good resource to go to is cloud.google.com. There's a lot of content on where you can start and what you can do. We also do have an amazing Medium publication on Google Cloud and what happens this week in GCP, and you can see what a big curation of amazing things. If you're thinking of getting a taste of what machine learning is, Google did release a nice, amazing course called MLCC, Machine Learning Crash Course, which you can start. But above and beyond, this talk was more on big data and engineering and thinking about it. Quick Labs, which is this already provisioned tool that helps you do code labs and learn a lot about what you can do, can help you learn more about big data and infrastructure and setting up that as a managed service. So, there's a lot of cloud architecture and data engineering courses that you can take. And Quick Labs is really cloud agnostic. It's not just Google Cloud. It focuses on everything, AWS, Microsoft Azure, Alibaba Cloud, any type of cloud. And actually, one of the big issues that's coming out is, these guys are evil guys trying to lock us into one perspective. In vendor locking is like a big issue with majority of customers and the likes. And we started seeing like initiatives such as cloud native, where my technology run on any cloud service. And that's why you're seeing efforts such as Kubernetes, being there serverless as well. The serverless framework allows you to run, sort of serverless architectures on that. We're seeing a lot of the conversation now going on cloud native. Can you run it even on-prem, right? And so the knowledge is more so universal on any cloud provider whether you go on-prem or on a cloud provider. The only trade-off that you have to think about is the build versus buy, and also how much you want to invest in one cloud service and another. I've seen architectures that have people use 30% of AWS, 60% of GCP, and I've seen vice versa, and people spreading their ecosystems around. So, it's for you to just decide which one works for you best. Leave like 6 minutes for Q&A, and then, we can wrap this up. Any questions?
Thank you very much, Kenneth.
Yeah.
Going back to your definition about what big data really is,
Yeah.
Everybody's talking about it. One of the things that I'm always trying to find out is what local case studies do we actually have where people have large enough data sets that they're actually putting this technology to use. Whereas if they did not use that technology, they couldn't derive the value that you're talking about. So I'm thinking about, people usually talk about Safaricom with all the M-Pesa data, all the call data, and maybe KRA with all the transactional data on tax and all of that.
Yeah.
But I'm really looking to find out what are the practical local examples of this tech being put to use and what value people are deriving from it.
Yeah.
So if you can share some experience that you might have.
So based on my knowledge, I do know like Safaricom spinned out like an alpha team that came out, and I know one of my friends, Chris Orwa, joined them, and he's like one of the guys I know who has a lot of experience sort of doing this at scale. I can say maybe they have started thinking about it or working on the infrastructure to sort of do that. I can say that iHub research, when I was working at consulting, I used to work at iHub Consulting, and I can say that they did a couple of local projects. We had an iHub cluster, and I know Chris Orwa personally worked on a couple of projects that were, they went into Twitter, did a whole, dug around Twitter, did some semantic analysis, shared some sentiments. And I remember there was a project and a paper written on that with iHub Research. So that's one. It wasn't commercial, but it was more like research-based. Another company that I can say with knowledge is like Twiga, but I can say they're not doing like the machine learning AI things. They're using that data to sort of inform them on the next steps. So remember the puzzle that I said, you don't have to, so everyone thinks of this big silver bullet that is machine learning and AI. So for them, basically, they're using their data well to sort of inform them, and they're growing exponentially. But they're also, their ecosystem, their infrastructure, like the microservice and the likes, is growing at an exponential, right? So they'll sort of get there. The people, so this is just like my own hypothesis, this is not like backed by any data, is like, this is what I feel. Majority of the companies or people that have the type of data that can give them exponential growth don't know where to start or have a lot of policy or red tape that hinders them to do it. And then the amazing startups that have the information are really looking for this type of data. Right? So it's like a catch, it's like a paradox where they are. But I can say like now with the knowledge that people have and the type of companies that we're seeing come out of Nairobi and also Sub-Saharan Africa at scale, and also like also other emerging markets, we're starting to see now companies becoming more data-driven based on like, investors are like saying you have to be data-driven. There's no like experiments. And so everyone is starting to sort of move into this. So I can say maybe we can have amazing use cases maybe in like 3-5 years that people now talk about what they've done on massive scale. But I can't see a lot of examples. I can say they're there, but they have not gotten to like that sort of massive petabytes scale, yeah.
Thank you, Ken. Mine is more of a practical question.
Yeah.
Okay. There's a time we were thinking of approaching Nakumat and asking them, let's mine your data and see some insights. But at that point, they also hadn't figured out the collection phase particularly well. I'm assuming that by now, a forward-thinking local supermarket chain like Naivas, for example, would be interested in a nice way if we package this in a nice way, okay? So from a business logic or a business case point of view, forget the technology.
Yeah.
What would you say they would need to do? Because there are some trends that I found very interesting. Naivas started doing hot food in certain places, and then in localities where there were a lot of young people, hot food took off. And the question becomes, what is the correlation between, say, Ngong Road devs and a supermarket and hot food, and how can that become a viable business? How can that be used later for prescriptive solutions in places where they're opening up afresh? That for me is the kind of wrap that we need to use to sell, big data and ML and AI.
Yeah.
How would you do it?
So this is very interesting because I just finished reading this amazing book on applied AI, and I can say that one, the factors are actually, so there's a lot of factors to play. One is there a business case that first? So the first thing is the why. Why should divers care about this, and does this technology help them? So for me, it boils down to one, first principles for any business. Can I increase my revenue? Can this thing help me increase revenue? 2, can it help me become more efficient by reducing cost? Or 3, can it help me untap new markets? So that's the first basis where I start. Then the second part is okay, we understand, this thing what's the certain small project? And in the case of a NIVAS, it will be what is that small project where I can do a small thesis and show them a very quick ROI, what are the quick wins? And if I was approaching it, I'll look at how can I get NIVAS or this retailer or someone who has this amount of data to sort of see an ROI. So there's also a business sense where you have to convince thought leadership. Now, once you convince the thought leadership, they also have to put an investment into actualizing this. So in Twigger's case, you could see that the founders who are non-technical before valued the impact of technology. So thought leadership at the time valued technology. They got Kane, who came on board, and there was no tech. And then he started thinking about tech. And then they have had a massive investment in their technology. And they are a really nice case study that can prove to other companies. So these are guys focusing on bananas and retail. And they have brought tech at their ecosystem, at their epicenter. Now, if other companies can be able to see, because everyone keeps asking, who has done this before? Now, at least we have a case study. We can say, Trigger Foods has done this. They're in the banana business, and they have this sort of thing. So first is building that type of case for thought leadership, and also telling them, hey, you need to invest this type of resources to get this value. So that's the first aspect. That's how I'll think about it. And then thinking about now, what are the areas to start with? So the first thing basically is thinking about the data they have and getting the right data engineers to sort of look at the data they have, their ecosystem, how big is their data, how much have they collected it, getting a data scientist to sort of clean that data. And then from then, they can now define, okay, this is a project we can do. And so it's no more of a how, but it's more of a why and a what. And then if we can now have a nice use case that we can show them, I think we can have some success. But it starts with thought leadership. It's what I ended up learning in my previous company was we were in the fintech space. I can say confidently that tech is just 30%. The other percent was lobbying, regulator. The regulator will wake up one day and tell you, hey, you guys, you need a banking license, or it was just crazy. So there's partnership, there's consensus, there's always selling, always trying to convince these guys that you're good. So it was that was majority of the time I spent trying to convince guys, yeah, we have the tech that can work, and we let us do something and test, right? So I think that's the approach that I will take. I think I'll take one more question and then we can close. One more question. Okay. Yeah. Let him just ask his question, then you can finish.
So it's interesting that Jimmy talked about Nakumat, because actually with some friends, everybody was saying this huge data set that sits at Nakumat could actually be mined to create some real value for other players coming in. One of the problems, by the way, my name is Wilfred, I forgot to introduce myself.
Okay.
So I do a lot of work with government in terms of data initiatives, mainly in agriculture. And one of the problems has been data is everywhere, but not really somewhere. So one of the areas we've been trying to work on is how we can have a data interchange format that allows data to move across, so then you can consolidate all these data sets.
Yeah.
I'm just curious to hear what your experience has been with government, particularly when you propose the idea that you could have all these different data sets and you could bring them together, and whether there's been any developments in that area.
So I've not worked with the government, but I can share some of my experience on how I've seen this being tackled in other markets. So one is having a sort of like, okay, the players coming together and then saying, okay, let's agree. For us to thrive in this ecosystem, we need each other. And we've seen this as the fabric of also what has made Silicon Valley, where you see, many companies coming together and saying, okay, we need each other. So how do we work in this ecosystem? So one thing is bringing the players together and saying, okay, I have this type of data, you have this type of data, you have this type of data, and sort of, because it's fragmented, and I agree. And so thinking about now ways to come through. So I think Trigger Foods did do like a sort of project with blockchain where they were trying to see, it was just an experiment, trying to see, can they also share some of their transaction data in a more secure way for other people to sort of help them with credit scores and the likes. Because if you want to evaluate, let's say, risk in agriculture, you're thinking about it that way. But just to answer your question, I think what needs to happen with, let's say, government and the likes, this thought leadership, as I said, the first thing, then creating sort of a policy, then bringing people together, and then now the actualization, which is now them agreeing on what they need to do and then actualizing that project. That's what I've seen. I think there was a project with Uber and Lyft and I'm forgetting the other ride-sharing app, and they came together, they shared some of their data sets, brought it together so that they can help a city have better urban planning, for instance, right? Because they can know how people are moving. It's one type of data set, but they can merge it. So like in Silicon Valley, in San Francisco, I can give you an example. They took data from, I think, Lyft and Uber, and then BART. BART is the Bay Area Rapid Transport, so it's like the metro. And then the Muni, which is like the small buses. And then from there, that can inform you how people are moving and how you can sort of have better urban planning, which place needs roads, which place, So it's more about people coming together and sort of thinking of, okay, how can we work together? So it's more of that, because there's a lot of silos, yeah. I think there was one question there. And then I'll take the last one. Okay.
Hi. So what are some of the downsides to using big data? Like when a company is scaling and they think that, yeah, we need to grow further than this, we may need this. How can big data affect them negatively?
Biggest downside that I can tell you on top of my head is bias, unconscious bias. All of us I was actually seeing that the realization is that the age that we are going in the machine learning AI age, it's going to sort of make us unlearn ourselves as human beings about what character is, what is good, what is bad. So I'll give you a case scenario, right? There was a recent incident, I can't remember when, where there was a training data and then a black African-American person went there, and then they think the computer vision categorized this person as a monkey, I don't know, a baboon, right? And then for white people, it said that this is now a male human being, right? But people could, and everyone got fiery and the likes, right? But this was just a classic example about how we have bias in terms of how we train our data. And all of us have bias. By the way, it's not that they have bias. Like if you are building an app, you'll build an app unconsciously biased based on your environment and how you think about it. So if you take it to that market, it will also think that that guy maybe is like some foreign object, right? So unconscious bias, and bias is like how we train our data. How do we build AI for good or machine learning for good? How do we train the models well? Remember, you're training a computer just as it's sort of like, machine learning is just basically training a computer to sort of, a machine to sort of learn the way we learn as human beings, because machine learning is modeled from neural nets, how human beings work. And so it's the quality of the data and the variety of the data, the way you train it, that's how it will pick up those subtle nuances. So that's like one of the biggest risks about your data. You can have a very biased or skewed data set. And if you're reading from one point, so for instance, if Uber gave out their data set and they're like, yeah, this is amazing data set, you're only seeing the story from perspective of only people who go with Uber. Are you seeing the perspective of people who use public transport? How is that captured? Are you looking at the people who drive to work? You see? So you're actually, the whole essence of really, really thriving is based on having a variety of data points. I think Charlie Munger, this vice president of Berkshire Hathaway, says, yeah, you can have one mental model works, but if you try and force that mental model, you'll have like a biased thing. So you have to actually use many mental models. So I'll give you an example. If you're thinking about a startup or a company, you'll first start with saying, okay, what problem am I solving? How am I delivering value? Who's the customer? Then you start there, and then you say, okay, is there a market for this? Like, in the environment, are these people who I'm solving this problem? Like, is it big enough? Do they have the purchasing power? That's another model that you're bringing. And then you're like, okay, do I have the resource? So you can see that for you to just have like one amazing business, it's bringing many models together. Do you have the right technical know-how and the like? So if you're only seeing it from one perspective, you can say, yes, I ticked all the buttons. One, I'm solving a problem and delivering value to this customer, but that business doesn't make sense. It's not going to bring you money. So bias is like one of the biggest things that I think, in my own opinion. I'll take the last one.
Cool. Hey, I'm Maggie. So
Yeah.
my question is around collecting of data. How do you ensure that the data you are taking is going to scale? I.e., if you start a business today, you already know that you take in maybe the customer name, how much you're using for raw materials, and then how much you're going to be selling the product.
Yeah.
And then when you do the difference between the two, you know, your expenditure versus your profits, right? But how do you foresee when you want to see maybe repeat customers? And also, as you take in the data, how do you foresee it in a way that you don't fail to take in that data? Because he said that the first thing is data is everywhere, but nowhere exactly. So how do you foresee that you actually have that data from the beginning versus in the middle end, you're like, I want to analyze something, but I didn't have that data?
Yeah, so you bring out a very important point. And the way I think about it is, one, I use this model is falling in love with the problem and not the solution. So you'll find a lot of people are like, they have like, okay, data is the new oil and the likes, and then they'll focus on getting all this big data and doing all this massive stuff, and then focus on the user, right? Forget about the user. So what I'll first advise you is like, really focus on delivering value to your customer, number one. That's like the number one thing. Like, focus on that, and then now start thinking about, how do I give my customer a better experience? How do I do that? When you focus more on the problem, then you end up discovering what type of data you need to collect. So in this case, if you think about Trigger Foods, they could have gone and collected a lot of data points, but because their problem is very clear, like, supply chain, one, make sure that farmers are better paid and they can be able to have a ready market where they can sell their bananas. Two, retailers can be able to buy these bananas, quality amazing bananas at an affordable rate, right? With the least effort, like just order and it comes, right? So their problem is very clear. And so now it's like, okay, what are the data points that help us achieve this mission? And that's how now you think. So it doesn't start by you collecting data and then looking for a problem. No, it starts with you actually focusing on a problem. And that's like one of the biggest problems in machine learning and AI, where people think that, oh, putting machine learning and AI to give me like exponential growth. No, you have to really, really, really have a problem, have a project that's really mirrored on, okay, problem, value, to who. Once you have that, and that becomes your building block that informs you on the type of data and how you, so the value creation is now what informs you that the type of data that you want to do, right? And so that now tells you, okay, because at the end of the day, you can collect so much data and it ends up being noise. You know, it's like too much waste. You have too many logs, but if those logs don't tell you what to do or inform you, spend time like just removing. So it's not about, remember, it's not just about the volume or the quantity that you have, it's all about the quality that you have. So you might have terabytes of nonsense data or noise, right? And maybe the amazing data is just like 1 gigabyte out of a terabyte of data. So it's sort of, that's like the type of thinking that I'll advise you to sort of focus on. That will inform you the type of data. And then like, I think Kane put it in the keynote where he said like, follow your data. Follow like your process, follow that, and that will inform you like what data, the data flow. What's the data flow between your processes and your company and how you're delivering value? Yeah. Thank you very much.
Sorry, I've been given one more question.
One more question?
If you don't mind.
Okay.
Sure. So my question is a personal interest question.
Can we take it offline, or do you think it will benefit everyone? If it won't benefit everyone, let's just take it offline.
Okay, sure.
But if it will benefit people, ask it, and I'm just asking you in that. So think about it. You don't want to waste time for all these people.
Let me know waste time for that.
Okay, thank you. So, yeah, thank you very much and, for you being here, and I hope I was of value.